And welcome back. As we go ahead and continue looking at how to use Java to make class objects, let's go ahead and veer now into using class constructors. So the very first thing we're going to talk about is variable initialization. Local variables, which of course are variables that are defined, for example, to our methods, are not automatically initialized in Java. So you have to explicitly initialize them before they can be used. And recall that instance variables, on the other hand, are automatically initialized. So instance variables that are Boolean are set to false. Instance variables of primitive types such as ints or chars are automatically set to the 0 value of their type. And instance variables of a class type such as string would be initialized to null. Now there is an alternative way for us to initialize these instance variables. Although instance variables are always initialized, it's much more preferable to instead explicitly initialize them with a constructor, even if the initializing value is the same as the default initialization, such as 0. A constructor is a special type of method that is designed to perform such an initialization. We haven't really looked at constructors up to this point, but they are actually very important. So to best use our variables, we may or may not want to define constructors, and very often we will find ourselves wanting to define them because of certain reasons. So if we want to initialize an instance variable when we declare it in a class, we can look at this example for a date class. And you can see we say public class date, private string month equals January, private int day equals 1, year equals 1000. You'll notice that there is no return type in here. For example, there's no void, there's no string, there's no anything like that. Instead, it just says public class date. And let's take a look and break that down a little bit. So with constructors, when you're defining them, you do not give any return type for the constructor. As I already mentioned, there's no void, there's no string, etc. And again, we don't use void as a return type here because there is no return value for a constructor. Constructors also are typically public because we want them to be accessible to create those types of objects. So let's actually look at some constructor definitions. We've actually already been using constructors in our code without even knowing that we've been doing them. So for example, when we did our date first try class, we said date first try date 1 equals date first try. Guess what? That was using a constructor. The expression new date first try is actually an invocation of a constructor. Even though we didn't define in our date first try class the constructor code, it was still there. Now, the thing to remember about constructors is they have to have the same name as your class. So, for example, if you're using date first try, it would be a new date first try. If you're using a date second try, it's going to be a new date second try. So, the first occurrence of date first try in our example here above is the class name. So, it's date first try date 1. So, that's referring to the class name. And the second part is the constructor, the new date first try. If you add no constructor definitions to our class, such as when we first started with like date first try, date second try, etc., then Java automatically creates a constructor that's going to take in no arguments. Such as here, we have open and close parentheses. You see there's nothing passed into them. And up to now, these are the type of constructors that we have been using. Now, it is preferable to define our own constructors so they have them initialize instance variables or have some kind of other initialization action. Now, this is something we're going to talk more about in our next lesson, but overloading is something that's very, very important when we're talking about constructors. Let's look at the date class here, and we'll actually take a moment to go look at Eclipse here in just a few minutes. But in the date class, we've been using the overloading technique to create 5 constructors for this class. You know, it's perfectly normal, actually, to have more than one constructor for your object, because a lot of times it's going to be based around how many variables are you passing in for that class. Because every constructor must have the same name as a class, all the constructors in a class must have the same name. Now, when you define multiple constructors, you have to use overloading. And again, don't worry about what overloading is. We'll take time to kind of pick that apart more in our next lesson. But for now, just know that this is what it is called. Initialization for methods, if you look at the date class, again, we're going to take time to kind of pick this apart. all the instance variables you'll find have been initialized, even though there's no parameter necessarily corresponding to the variable. You can do almost anything in a constructor method that you would do also in a normal method. Like we could have it do calculations if we really want to. However, typically what you will find in constructors is that they're only there to initialize values because we want to say, here's the starting value for this variable. Now, constructors can have arguments. When you create a new object with the new operator, you must always include the name of the constructor after the operator new. And we saw this like new date first try. This is the way that we invoke or call a constructor to be used. As with any method invocation, you can list any arguments in the parentheses after the constructor's name, which is the same as the class name. So for example, date birthday equals new date, quote, December, quote, comma, 16, comma, 1770. This example would be a call to the constructor class date that takes 3 arguments. You have 1 string and 2 ints. This creates a new object to represent the date, December 16th, 1770, and sets the variable birthday so that it names this new object. Now, what if we want to reset object values or change them? Well, a constructor is called when we create a new object, such as with the operator new. And any attempt to call a constructor otherwise is illegal. So, for example, I say birthday.date, quote, January, comma, 27, 1756. This is an illegal invocation. Because you cannot call a constructor for an object after we've created it, you need some other way to change those values of the instance variables. Because, what's if we typed in the wrong date? How do we fix it? Well, the purpose of the setDate methods and other methods that begin with set is there to fulfill that purpose. So birthday.setDate, January 27th, 1756. Again, those mutator methods are there for a reason. And although it's not required, methods that reset instance variables are normally given the prefix set because it's a common convention for us to know, oh, these are the ones that change the value. So whenever we see those set methods, again, we talked about them being mutator methods, allowing us to change variables. The same thing happens here for constructors because constructors, remember, they're there to initialize it. And once those objects exist, we can then treat them as if we've been doing them any other way. Now, although you cannot use a constructor to reset the instance variables of an already created object, you can do something similar. So, for example, let's say we have date birthday equals new date, December 16th, 1770, and I say birthday equals new date, January 27th, 1756. Now, this second invocation does not simply change the values of the instance variables for the object. Instead, what it's doing is actually discarding the old object and allocates storage for a new object before setting the instance variable. Therefore, it's better, more efficient to use the methods such as setDate to change the date of the instance variables of an already defined object because, again, you're not having to deal with like memory allocation and stuff like that. It allows it to effectively rewrite it. All right, you're not, because of this first way that we're looking at here right now with birthday equals new date, you're effectively reallocating memory space, and you have the other one just kind of floating out there for waiting for the garbage collector to come along and clean it up. So it's better to use our mutator methods here rather than trying to just assign it a new value. Now here's a quick tip for you. If we want to invoke a method within a constructor, it's perfectly legal for us to invoke another method within the definition of a constructor. So for example, if we wanted to use user input to define something, we could. This is because the first action taken by a constructor is to automatically create an object with instance variables. You don't actually have to write any code to create this type of object. Java creates it automatically when the constructor definition has this object as its calling object. You can even include an invocation of one constructor within the definition of another constructor. And we'll see this if we get much more complex programs where you might have a class within a class definition. Now, a constructor also has use of this parameter. Constructors, just like any other methods, have a this parameter, and this parameter can be used explicitly, but is more often understood to be present, though not written down. So you're not really going to see the use of this in here. Whenever instance variable class is used in constructor without an object name and a dot before it, it's understood to have an implicit and dot before it. Whenever a method is used a constructor and the method has no explicit calling object, the method is understood to have this and a dot before it. Now, the first action taken by a constructed object is to automatically create an object with instance variables. This object is automatically therefore plugged in for this parameter. Again, this might seem a little confusing, but just know that this is something that happens behind the scenes. So if you're looking at all this and you're like, okay, I'm not quite sure of what all is going on, don't worry about it, because again, this is all happening behind the scenes. It's just a little bit kind of more food for thought. Now, this thing is, though, a little bit more important, which is the no-R constructor. If you define any constructors, it is usually best to define a no-argument constructor, even if the body of the no-argument constructor is empty. It means it doesn't do anything. A constructor that takes no arguments is called a no-argument constructor, or more often simply called a no-arg constructor. If you define a class and include absolutely no constructors of any kind, then no-argument constructor is automatically created by Java. Now, this no-argument constructor doesn't do much, but it gives you an object of the class type. So, for example, if I say my class, my object equals new my class, and I didn't define what it is, it's still going to function. And that's going to lead into this topic of automatic generation. If your class definition includes one or more constructors of any kind, then no constructor is generated automatically. So let's say we define a class called your class. If you include one or more constructors that each take in one or more arguments, so they have parameters, but you don't have a no-R constructor in your class, then there's not a no-R constructor, and the following would actually come back illegal. Your class or object is new your class. And that's because you've explicitly defined parameterized constructors, but you did not explicitly have one with no parameters. So the problem here is that that declaration actually requires to invoke a no-R constructor, but because you've explicitly defined parameterized ones, there is no R constructor for it to look at. So if we want to actually avoid these issues, it's pretty common for us to have a no R constructor in any class we define. Again, you can leave these empty because maybe you don't want it to do anything specific, but it's a great way to avoid potential issues. If you don't want the no R constructor initialize any variables, for example, you can just give an empty body or put no code inside of your curly brackets. Public my class, and then open close with those curly brackets, and inside it does nothing. And that's going to lead to our last thing, which is talking about the default constructor. A no argument constructor is also known as sometimes the default constructor because it's what Java is going to attempt to use in your programs. However, this term can be misleading because a no argument constructor will not always be provided by default. As we just talked about, if you don't have that code in there, it's going to lead to issues. As such, the term no argument constructor is often used instead. And here we are in Eclipse taking a look at the date class. You can see in here we have a couple different constructors. So we have this public date, and inside it just simply sets month to January, day to 1, and year to 1000. So that's all it's doing. It's simply just setting those instance variables. And then in here, in our other ones, you can see we are using this set date invocation instead. And of course, there's other ways we can handle this. We, of course, could still set it to corresponding values, like month could equal certain things. But we're using the set date because, remember, set date allows us to check to see if these are valid entries. So that's why we're using the set date invocation here instead of simply just saying month is equal to month int, day is equal to day, etc., etc. So this is, again, a great way for us to check to see if those are valid. And you'll notice the difference between these. This one takes in an int, int, int. This one takes in a string, int, int. This one only takes in a year. And this one actually takes in a whole date object. All right, and so we'll talk a little bit more about this when we talk about overloading constructors. But again, this is just some good examples for us to start looking at and seeing how those are used. Now, if we go ahead and look at that in a main class here, I have a date 1 equals new date December 16, 1770. We have one that's a new date 1, 27, 1756. And we have a date 3, which is simply just passing in a year, and one that's simply just passing in a no arg. So if we go ahead and run this, we can see our first one gives us December 16, 7070. We have one that says January 27th, 1756, because again, it's pulling in this numeric value and converting it. We have one that's January 1st, 1882, because it's pulling in this. And remember, it's going to, if those values aren't set, it's going to refer back to whatever these kind of no arg values are set here. So that's why we're getting January 1st. Even though we haven't defined it, it pulls those other values in, because if we look at that one that's pulling in the year, what is it pulling in? 1, 1. So that's why we're getting January 1st. And then the last one that just says the default date is January 1st, 1000, because that is, again, using our no arg constructor right here to go ahead and set and assign those values.